Okay, welcome back everyone for the general panel discussion where we can revisit really any of the topics today. The general title is Nature of Mind and Consciousness, and maybe I'll start with a question for Paul or for general discussion on the limits of knowledge. There's an optimism that may, in scientists, shade into hubris that we can understand everything. So my question, fairly obvious one, is one of the limits to science is maybe us. And for instance, in the realm of string theory, the master of string theory, Ed Witten, said it was some 21st century physics that dropped into the late 20th century, and we may not be smart enough to figure it out. The theories of mind may be in that category. So do you think it's possible that this is a problem we're just not smart enough to figure out?
I believe that's the case. And in particular, back at the end of the 19th century, I believe it was Laplace that found out that there were some very simple systems of planets going around stars that Newtonian mechanics, this ruling paradigm of science, that things could behave like balls and fall into gravity, and you could, given their initial conditions, you could predict their positions forever, that chaos came in, that the interactions of three simple bodies could be so complicated that none of our mathematics could predict beyond a certain period of time where these bodies would be. So even in the case of seemingly simple Newtonian mechanics, we know there are limits to our actual ability to predict the future. And so when we think of these the words emergent properties like consciousness, one of the things that may mean is that these things are simply not understandable in our current framework of science and mathematics.
Okay, here's a question I'd like to direct to the Geshes from the audience. I mean, I'll simplify it a little. And any or all of you could answer this. In your view, what has been or is or will be the benefit of the dialogue between Buddhism and science? What do you see as the point of it or the benefit of it from your perspective?
The Chezan Tanda Pardunganzo Nanju dan Serik Pard Dinek and Rolling Mongus to the Sonza, Kananzu Nguyen Day Yung Duzambala and the Rolling Ki and Pendo Kariung Sari Zamgudus.
That to the Lynch Gavra. No. Chitane Tangaranchi Regina, Terisiri, the Subjon the Tamboyi. Tangarang to Samzui Mado and the race in its own shit of Mendo. 3D 낭초당 세린이 소버지나 펜도 가리용사레 슬라인도가라 페나 낭초네 즉 뒤텐기 남샤 망부지 즉 세가 매대와 덴제지 페나 식 남샤 세가 매대와디 즉 오다 낭초레 펜지 제 세린이 세린나니 셈기 남샤 띵사부 쉬우지요다 다 셈중 코로나 즉 남자한테 지당 쉬우지요다 남기 남샤도 파샤 덴제디 세리라파 펜도 두투멘도 삼고도다 디인도가라 핀순이가 된 도도는 핀순이가 찌기 카 마세디 찌기 카세야 찌기 마세디 찌기세야 핀순이가 펜도 메로 삼고도 디기톤
In Buddhism, like there are areas of studies like the particles, which are not so clearly mentioned in the text. And so as far as this kind of subjects are concerned, it's very much clear or much more deeper in modern science. So the Buddhists, we can take this knowledge from the scientific community, and we can gain knowledge from the science by having these kind of dialogues. And when we talk about the mind and the concept of consciousness, then we believe that in Buddhism we have a detailed descriptions about different mental states, mind and mental factors and mental states. And by having this kind of dialogue, we believe that like scientific community can gain insights from Buddhist partners. And so through this way, we can both enrich our knowledge by sharing what is best known to us.
Can I add something?
Sure.
Okay. Whoever asked this question, thank you very much, because thanks to His Holiness the Dalai Lama, now we every year we are having these programs more and more, and it's very important for us to have a clear picture of what we are going after. Whether you are a Buddhist or not, it is very important that we know what the scientists have found, because what they found and what they are talking about is not something something only for them. It's universal. When you talk about neurons, you're actually talking about me, so I have to know. And just to entertain you, I think you can draw a parallel line. Like in Buddhism, we say, he's not a bad guy, it's just, he's angry. So I think you can say he's not a bad guy, it's just that he has, the different chemical reactions in his brain. Or you can say that, like, to detach yourself, that she's not so beautiful, it's just the way her skin cells are formed, I don't know. Or you can say that his color, his skin tone is not so bad. It's just the way wavelengths deflect from it, I guess, So what I'm saying is, I don't think from these dialogues, scientists, I don't think His Holiness is looking for you, waiting for you to accept a consciousness that is other than mind, brain. I think what he wants is, he wants you to take examples and the explanations, vast explanations the ancient traditions have, and use it in your own field to understand how brain works better. I guess I might be wrong, I'm sorry.
No, that's great. I think you're pointing out that, and as was very clear through the day, that the traditional scientific approach of which is not just Western science, as has been pointed out, the world of science works pretty much the same way, has had some phenomenal successes, and has had some things that it has not succeeded at all, and some things that it's not cared about. And maybe, it's time to change that. And I think the thing I resonated with from the morning was this amazing dichotomy over the fact that, in these personal, subjective states that are extremely clear to the individual. So you don't need Western scientists to explain your sense of being. You have your sense of being, right? Western science cannot validate it. A theory of mind cannot validate something that you experience. Neither is it needed or can it validate a sense of contemplation or meditation or the well-being that results from it. But what Western science clearly seems to need is new methodologies for moving in the direction of being able to benefit from these awarenesses of Eastern religions and other ways of thinking about the being. So I think I'm interested in other people's thoughts on what new methodology science might, from having the third, so it's this third person, first person issue, and how do we just get a little beyond that or have new approaches?
So I totally resonate when I first, read William James 100 years ago talking about how an empirical science of subjective observation was needed to move the science of mind forward. I resonated with that, and I believe that really is the methodology that needs to be brought introduced into the domain of Western science that the contemplative traditions are so well versed in. A few years ago I was giving a talk to some of my colleagues in psychology at UC Berkeley, and I was mentioning something like that, and they said, well, what are you talking about? We already have methodology to empirically describe subjective experience. It's called the Likert scale. I mean, now that's a technical scale in experimental psychology, but for those of you that don't know what that is, it's how are you feeling on a scale of 1 to 10? That's the level of sophistication, that a lot of psychological science and Western science has done, and that doesn't go very far with really understanding the kind of the deepest recesses and connections of consciousness. So this is huge, to introduce this methodology, this technology of looking inward, and incorporate that some way with everything else, all of the power and technology of Western science. And along with that may come, something that the contemplative traditions have not been so interested in, is to look for some kind of mathematical, theoretical framework or something like that. This is something that Western science is very good at. I mentioned briefly at the end of my talk on one of those slides, it said something like expanded metaphysical framework, where experience is given essentially a similar status to what we give space and time in our current metaphysical framework, so that there would be some kind of fundamental acknowledgement that from the beginning one needed to have an experiential component to sort of explain all of reality at kind of the next level of incorporation. Now, that may not explain everything or something like that, but it's an interesting hypothesis to entertain, and there are philosophers that have introduced these ideas into Western science, 100 years ago, but they never really got very far. It's an interesting hypothesis to entertain, that if you adopt this expanded framework, does it take you into some new places and provide some experimental tests and so forth?
And this is from the audience. This is a almost generalization of the previous question. And maybe it foreshadows the last panel tomorrow when we talk about serving humankind. What is the purpose of doing never-ending research in science?
Well, I mean, it's a really interesting question, and profoundly interesting question, and important question. We humans seem to be eminently curious beings. It has something that may have evolved along with our greater cognitive capacities to help us get along in a complicated world. I mean, if you take the standard perspective in biological evolution, our brains and our mental capacities have developed over evolutionary time to facilitate our survival in this complex environment. And part of that has part of that has involved being adventurous and curious about exploring for new places to live and sources of food and new ways to survive and so forth. So in some sense, our intellectual curiosity about all of this is part of that evolutionary tradition. You know, we do it because we're curious beings. And for me personally, that is part of the motivation. I think it's a fascinating challenge to really address this. The most interesting question that I could think of asking is like who am I? You know, how do I know what I know, and how do I fit into the rest of reality? I also believe, and this is even a bigger motivation for me, that the kinds of things that we are discovering in this endeavor are allowing us to develop a greater appreciation of how interconnected everything is. Even if we just think about what's already happening in conventional Western science, we appreciate more and more deeply how interconnected, you know, everything on the planet Earth is, all the environmental, you know, impact that we have, the biological processes with the geology and the atmosphere and the weather. And this is a tremendously important lesson. And when it comes to human consciousness, I believe that the results of this kind of investigation will lead us to a place of greater appreciation of how interconnected we all are as humans, and how interconnected all of life is. And that will foster greater ethical, more compassion, and improved ethics in the way that we conduct our lives. That it can't help to have that side effect to it by appreciating more deeply, more deep interconnections.
Yes, I agree with all that. Science is useful and changes our lives. And I have to add one more thing. For me, to find out something that nobody's found out before is just plain fun. And it's good to have a joy in your life of discovering things. And it's also a joy to share it with people, to be a teacher, to share what you've discovered. So the science provides this double opportunity to bring joy to my life and to many others, I'm sure.
당기 긴 볼라기 아니 지딘 탄성돈 제이투네 아니 조지 쉐디 아니 당기 제주 난당 난다와이나 지디긴 탄성 동보들 아니 버가 나보다 아니 디니게 준비게 아니 드칭게 토라니空中생이지가 아니 드칭지 드칭게 아니 드니게다 차오 딜리게 말아 차시지 마투게 아니 군주게 드니 空中생이 아니 탄성질라 시리 들어와 lauta nang ne dangin jeshi nang dang tawena lauta tungju deres an tuji jeshi nang su denji indo ani nge de chin de la ani ji khado da lob da ani de chin sung de la ani cheba gadis tu ni ji ge oren sin ge zhuo xue ji da yana lauta de chin li xinba ji de ani de chin khoro rang cha de oren sin ani digu tu la ani cheba de gadis oren sin ngi xue ji de tujina.
This question is for Paul. And it is related with the limits of knowledge. And when you talk about the limits of knowledge in science, you talk about this event horizon of the black holes. And also you talk about the fundamental particles, like at quantum level, you have these quantum particles, the quarks. And when you talk about the quarks, you talk about a specific wavelength, or the smallest possible wavelength beyond which you cannot go deeper or smaller. And when you talk about that wavelength, and do you mean that this wavelength is a property of that particle or the quark, or the wavelength itself is the quark? And other part of the question is that does these quarks do they have colors or maybe shapes?
So David concluded with a very nice slide that showed all the particles of the standard model in physics, and one of those is called a quark. And all particles are wave-like and particle-like. And those words sound like common words, like maybe this pen is a particle. But we scientists layer on some other meanings to those terms. And what a scientist means by a quark being a particle, or an electron being a particle, or a photon being a particle, is that its energy is created all at once, all or nothing at all, and it's destroyed all or nothing at all. It's a unit, it comes as a whole, and yet, as we calculate where it's transmitted and where it originates and where it's absorbed, the path in between we have to use its wave-like nature to calculate. So I think the answer is that the quark or the particle is both wave and particle. It's always created and destroyed as a particle, and it travels as a wave. Now there are properties to these particles, other properties like its mass, its energy, its electric charge, and there are some other properties, and we have to sort of search the world for what we might name them. And quarks, which are the particles that make up the protons in a nucleus, have this other property, and it has 3 possible values. And electric charge has 2 values. And Benjamin Franklin picked out the names for the electric charges. He called them plus and minus to remind us of the 2 properties of numbers, positive and negative numbers. And the scientists, when they were faced with picking out the names for 3 properties for quarks, used this metaphor of color, because you can make the largest number of colors by adding 3 primary colors of light, red, green, and blue. And so we chose those as the names for the quarks. But they have nothing to do with the actual colors that your eye can see. It's just a metaphor that helps scientists to remember this zoo of particles.
Yeah.
다 토마들라 양조 뜻들이 쉬어이 다 담원이라 지 지워 마고 그러네 다 땅아주고 신이 개개니라 다 문조들라 다 구두치시 되는 마 지워 주기 다 지워 쉬어 가인스나 땅아주고 다 대생되나 당게 시제이 캡지 직체 내가 나시게 빛이 보주세 지어다 세비 시저 디토로 빛이 보주 다 디기 지워 쉬어야 되게 데비드라 쉬어이 다 빛이 보주세데 지단에 백한디지래 시간지르시세 대야 아주 딱지 치고에 계시무도 와. 다 시간 남샤디 다 안주데 지단에 남배기다 체리 슝라고래 시 남샤고 라고래 디나라 세우시우지어다 레레시 드라마와체 다 백이 남샤디 베세디 다 리버 땅야를 백톤 리버군이 빼나 셰바 두빈도 갈라 단다 빼시 푸주 고라에데 조 가르스나 군수 숙제에도 군수 하고 되고요 다 빼시 푸주디 다빼 간제 톤 하고 되고 다 수미 시 수미 남샤디 간제 톤 고도 슬라인도 갈라 다 아주 남베기 톤에 매와 말다 요되어다 빼나 아주 남베 톤에 바 단다 우미 남샤 셰베 가도 갈라 오 랑지 주베 리버가 돌라 아 셰바 두제 요레 랑리니가 두디고 빼나 다 딜라 디시 자모 와시 드즈 촐라 두도와 어디 인도 갈라 빼시 푸주세디 지단에 빼다 시세디 남바 중나리 요되어다 디 인도 갈라타 누주베 체리베 뭐네 시수미 인남샤 땡 파윈도 갈라 빼시 사바 가요나 다 지워직딩이 다 도도라우디 다 당기되는 게 지워다 세시디 또 제니시데 있어다 가시 가버지도 디도 지워 도도되인다 체리기 남직 수미기 남샤 하고야 될 빼시 간디지 단다봐도 니 예나메나 디토라 베진 슈기 예나메나스다 직 지워직딩이 다 데네 카자다 다와직라 파게 로종라 치레 두두가 테블로 인도가라 단다 군주기 다 레베 제스 다 강치네 유도나 유셰네 레베 제기 톤 셰레스 데리 셰 송용도와 다 디송에디 균젠데 카레페나 균젠데 카레 슬라인도가로 균젠 고인도가라 페나 레베 제기 셰고에 균젠 고인도가라 칸지 고용도스나 페나 수레지 통과르지나 페나 수통인도가 레베 제디기 통화 인자 수통라기도 와스 디 인자 미셰디 레베 제레스 디 균젠시 고데기도 남샤군데 다 딜랑에 남베기 직 릴랑기 톤에 직 태와시 펜바르지나 나라에 지어와다 나 da lai jorwa tiang lebe jej rebes lebe jej re da mares kiti lebe jej na ta jingba ya da madu kala khakurwa di indu gala da se di chazang le khabe sura chirwa di khande ina da de lebe jej rebes chivani di di tuchena.
Every word must be correct.
I think there's no way that I can translate all the words that he has said in his caution. And there are two parts of the two cautions. And the first part of the caution is that today's topic is actually related with the limits of knowledge and the paradigm shift in science. And when we talk about paradigm shifts in science, we need a paradigm. We feel that we need a paradigm shift when we face some challenges or some problems, and when we face some limits in the scientific field. So when we talk about the consciousness and the non-material phenomena, do scientists have or had envisioned a paradigm or the scientific frame in which you can actually talk about this non-material and the consciousness and other non-material phenomena? And that is for David. And the second question is that when I have been listening for the past 1 month to science teachers, and especially the neuroscience teacher, it seems that whatever we think or whatever we see, all the consciousness, all the perceptions are because of these neurotransmitters or the chemicals that is related with our thought and visions. And if that is the case, then when we talk about the idea of self or the theory of self, is this self is also related with a neurotransmitter? Or the other way of putting this question is this: is there a specific chemical substance or a neurotransmitter that is responsible for having the idea of self or the self? If that is the case, then that neurotransmitter exists only in the brain, and because of that, self has to be exists only in the head, above the shoulder. But the self we think is that is pervades whole of our body. And so, what is your take on this kind of stand?
I could try the first part. The answer is no. There's no theoretical framework in physical science that is suitable for addressing the phenomena that we've been talking about, unfortunately. The successes of physical theory result from a paradigm that involves interchangeable mass and energy and 4 fundamental forces. And the mechanisms that relate those fundamental forces into a unified theory are the subject of current research and speculation. It is conceivable that in the cutting edge of string theory, other manifestations of these underlying elements of nature will manifest, other mechanisms, other manifestations. But the theory is extremely immature and extremely difficult. So at the moment, the answer to that question is no. And in a sense, the problems that the physicists are trying to solve are so difficult. They are busy trying to reproduce standard quantum theory from a very much more difficult basis in string theory. So there's no sense in which they are in a position to address the issues we've been talking about. So there's a theory deficit is the simple answer to the question, and an opportunity. Where there's a deficit, there's an opportunity. The second part is a great question, and then in fact let me attach it to question from the audience, very simply phrased, which is, what's the relationship between self and consciousness?
Okay. Yeah. Well, to address the neurotransmitter thing first, there's a lot of, certainly neurotransmitters are the chemicals that the brain uses to send signals between cells. And the brain is extremely complicated with billions and billions and billions of nerve cells continuously signaling one another with dozens of different neurotransmitter chemicals, trillions of times every second, probably. So it's never possible to say that there's one neurotransmitter that's responsible for a particular kind of perception or emotion or sense of self or something like that. It's always a complex symphony of many, many different things happening at the same time all over the brain and interacting in a highly complex way. So, however, the question of whether the sense of self is somehow mediated by the brain in some complex way involving many chemicals and many kinds of signaling is certainly one that's taken seriously by neuroscientists. And the conventional view would be that it is, and involving the body too. I keep saying brain, but really any sophisticated neuroscientist would say that the brain is highly interconnected with the rest of the body, and we sometimes don't know what's going on in the brain and what's going on in the body. So all of this is important, but there's some kind of neural integration of information that's coming in from our sensory perception of the world around us and how our body is moving in the world and what we see and what we touch and what all of our muscles and joints are feeling and the way we move. And out of that we build up some sense of our body, a perception of our body, which is quite, which has been, you can do things to the brain to manipulate, or you can do things to the body to manipulate how we actually perceive our body. Very simple things, like, for example, if you do a simple experiment where you're tapping on somebody's leg under the table, and then tapping on the table with exactly the same rhythm as the leg, and you do that for a while, the person begins to identify with the table. Now how would you prove that? How would you do an experiment to measure that? Well, you can show that if you then take a hammer and you get ready to hit the table, that the person will react much more strongly if this tapping has produced this rhythmic kind of connection with the table. It's as if they've extended their body to become the table in some strange way, something like that. And you can do even more sophisticated versions of that to show that our sense of what we consider to be our body is somewhat distortable. So there's no doubt that somehow brain activity, we have a map of our body, in our brain that is corresponding to the way that we perceive touch and temperature changes on our body. So there's no doubt that whatever our sense of self is, it is partly related to all of this body sense and how the body moves through the world. Whether that's everything is certainly, because that gets at sort of more like what is the nature of our ability to be aware at all. That's part of our sense of self. And since we don't know what the basis of that is, it's not possible to say. So there's something going on in the brain, but whether that's the whole picture is still part of the mystery that's remaining to be explored.
Yes.
Sir, I think this is for you. As scientists have so detailed explanation of many things outside, and also about how our neurons work. But something you said, it stuck me in. You said everything we know comes from our sensory organs and minds. So So how can we be sure of anything outside when we don't really know much about the mind? So, I mean, in many cases, we know that what our mind projects is not really outside, as in the case of color. So I was wondering, that's supposed to be my first question. And if I may, when you say paradigm shift, are you suggesting that that the scientists should lean towards the possibility of a consciousness other than the brain, or are you saying that the scientists should use the Buddhist viewpoint and to enlarge their understanding? Thank you.
Yeah, all of those things. Let's see. Well, let me address the last one first, the paradigm shift one. And that is that I mean, it kind of follows on what you were just saying, Chris, in answer to the previous question, but we currently do not have a framework in the physical sciences to accommodate consciousness. And that some kind of expansion will possibly be needed to do that. Maybe not. Maybe it will all just emerge if we can solve string theory and unify the forces and better understand the brain. Maybe an experience will somehow be there. I doubt it. I mean, my money's on that we need some kind of expanded framework. We don't know what it is. I think the contemplative perspective is a powerful way of expanding our understanding of what the mind is and what consciousness is. So I believe that has valuable contributions to make. I don't believe that's the paradigm shift. See, I think the paradigm shift is in a new direction that will come from an appreciation of what the contemplative traditions have to offer as inner telescopes, and what physical science, what can be built already on the foundation of a very powerful physical science by expanding it in some way. And one possibility is that some kind of consciousness dimension or component or coordinate or whatever we want to call it using mathematical metaphors will need to be added in as somehow fundamental. I know one person who works in string theory, kind of at the periphery of string theory, who has suggested that maybe some of these extra dimensions in string theory, which the mathematical string theorists don't know what they represent, maybe there's some room in there for mentality. Maybe that would be a way of introducing some of these into physical science, and it's kind of an interesting idea to explore.
Is that progress when we go from grasping at straws to grasping at extra dimensions?
Yes. I mean, is it progress? No, I doubt it. Maybe. But it's interesting, at least metaphorically. So what was your other question before that? Briefly.
I have to read again.
Just to remind you.
If everything we know comes from our sensory organs and minds, how can you be sure of outside world?
Well, yeah, I'm not sure of the outside world. I think we can't. At some very, we infer what some kind of existence because we all are able to in science. We make these measurements. We agree on the kind of repeatability and we build up this picture that has been reliably reproduced over centuries now in some ways. So it gives at least a very powerful illusion that the universe has a particular structure to it. But what really is going on out there, I really don't know. Yeah.
In fact, to follow that up and just be very provocative, there's a perspective, if you take seriously the idea that we're not either the first nor the most advanced intelligent civilization by far in the universe, a civilization with really only modest projection of our capability would be able to create synthetic creatures like us, computationally, without biology. Now that's a sort of dematerialist philosophy. but if you work out the numbers, the computational power required to create the history of all human thought processes on Earth is within reach in a century. And once a civilization can do that, it's cheap for them to do, and simulated entities like us are likely to outnumber the real biological ones. That's one proposal that's out there. A physicalized version of that involves the fact that we harness a 10 billionth of the energy of our star, and not very efficiently, using fossil fuel. If you're a more advanced civilization who can harness maybe 10 or 1% of the energy of your star, you have enough resource and energy to create a physical simulation whereby everything we experience and measure with our science methods is constructed. You know, you only need to simulate the universe with sufficient veracity to image the stars and the galaxies that we see with our telescopes. We've only just pinpricked the Earth, so you just need to make the physical Earth. It could be hollow, you know, and so on. The planets that we've just inspected a little bit, again, are just facsimiles. And so, you know, we could just be all the playthings of some civilization, or this is just our little playground that they created for us. So these are extreme positions, but philosophically, you know, they're worth pursuing because they're actually quite hard to negate. Here's one for Paul. There's a little concern lurking in this question, I think. Is it possible to create a black hole on the Earth, or has anyone tried?
So there was some worry that when we turned on the Large Hadron Collider, it might create a black hole, which would then have enough, small though it may be, gravity to pull in adjacent atoms and become larger and more massive and eventually swallow the entire Earth. But luckily for us, that didn't happen, nor was it likely to happen, because nature has been conducting this experiment on Earth for the entire age of the Earth. For the last 4.5 billion years, the projected, what we believe is the age of the Earth, cosmic rays with very large energies have been hitting the Earth, striking the Earth with the same energy that the Large Hadron Collider would be producing. And they have yet to produce a black hole that ate the Earth. So whew, that's good. The black holes that we begin to have evidence for right now are all more massive than 3 times the mass of the Sun, and they go up to billions of times the mass of the Sun. We've not seen any smaller black holes, and theoretically, the theoreticians do say that during the Big Bang, some small black holes could be created, and so someday we may have one pass through and detect it, but we haven't detected them yet. So I'd say the experimentalist answer is we haven't seen them yet. Good. And the theoretician's answer is it's possible they could have been made, but it takes a lot of energy, a lot more than the Earth has experienced in its whole history.
This one is interesting because it's a different flavor that we haven't heard before from the audience. It's just a question of the fact that that a lot of physics concepts seem to be based on have a mathematical basis, and therefore might not even necessarily exist. And I'll comment briefly on it. You may want to say more. It's interesting. The mathematical basis of physical theory is profound. You talked about if Feynman were given one sentence that was the most important thing to say about science, it's that everything is made of atoms. In that same interview, he was asked what he would add if he could say a second thing. And what he said, it's a little more esoteric, is that symmetry principles underlie all the laws of physics, by which he meant that the conservation laws that are the basis of physics, conservation of energy, conservation of charge, the symmetry between matter and antimatter, those are all based on they have a mathematical basis. And general relativity, of course, has an extremely elegant and profound mathematical basis. And so all of our most successful physical theories are mathematical in essence. And that is a counterpoint to Paul's correctly posited experimental basis for science. There is some Platonic thread in science which addresses a mathematical and very abstract basis. And it's an open question as to whether that mathematical basis could ever extend to consciousness in the brain. And it's sort of why I feel a theoretical insight or revolution may be needed rather than an experimental revolution. Do you have a comment? In terms of limits of knowledge and the nature of knowledge, do you have a comment?
I'll add in that it's been said by other scientists, and I find this to be true, that it's amazing that we can write things using the language of mathematics that describe the world in the following way, that if I tell you what I'm going to do, what the experiment I'm going to conduct is, very often these mathematics that we know how to write predict what the outcome will be to within some error. So it's just amazing that mathematics actually works in physics.
And this is there's another question from the audience this connects to. According to Stephen Hawking, if the unified theory is successfully constructed, then we can explain anything. Please explain. And that's interesting because the idea of a unified theory of nature is that you attain some very high degree of unification and simplicity in your mathematics. And in some ideal case, you have one equation or one set of equations that's supposed to explain everything. And of course, the irony is that if you ever attain that, you don't explain everything because of the hierarchy problems I mentioned, where your grandiose physical theory with that beautiful, elegant basis is completely inadequate to explain the complex scales of 10 to the 12 neurons and their 10 to the 15 connections, or the 10 to the 28 atoms in a human body, and so on. The reductionist approach fails, and the deterministic idea fails. So the mathematics doesn't help you, unfortunately, even if you get that wonderful so-called theory of everything. It's not obvious that it helps you with the topics we've been discussing.
Theory of everything never includes consciousness in the everything. You know, the people that talk about theory of everything are not interested in mind, mentality, consciousness, and just kind of tacitly believe that somehow that will pop out of understanding the brain better.
I have a question for the Geshes. It was something that came up briefly this morning, I think, in passing. After hearing Paul talk very elegantly about the triangular bounds to knowledge and mass and radius and the theories that underlie them, somebody made a comment after translation that in the Buddhist philosophy and understanding, there are ways in which you can know everything, that those boundaries are illusions, if you like, maybe of our approach. I would like to hear more about that.
Kishizula Tiwashidus, Teza the Indizabal, the Tanashoge, Ke Zoting Kapsulis, Kamuchum, Wiki, Nizuchik, the Tewayo, Chati Yuris, Teza again, Paul Koran Kitanda, Shoge, Dus Kamuna, Kapsula Koran Kitanda, Sheji Chapse, the midst of knowledge, like the Golshi in Duzambala, that the Lazamanzuki, Shin Tobiak, Sedi, and Sansam Kashil Duzambala, any Gardu Wiki, any Gages, Shevres, in Angela, Galagic to Sunduzambala, Nanchuk, Nan, She in Duzambala, that Anjidir. Chigi, any Mobudinsul relation, and Tangatsi to Stage Tandewale, Suzuk Nan, Semriko Tanje, any Sama and Shin Tobiak, Tabam Yuri Lach. Songs, Cheza, and Tizol, Mansungis.
Hello. Tangi Shevana Shirwa Karsa Chidane Shiji Capse Sedi, Tangi Tos Devach Majana and Digmidua, Tangini, Rua, Shiji Capse Sedi, Shejala Tayomare Sedi, Chidane. City Nambiniga Tana Page Patsishina Tungu Yorda. Candish Tungu Yorsina. Tanda City Beki Shig Namsha, the Samutai and Dugala. She Namsha, Zuni Shibi, Shig Namsha. The Karsa, Subjengi Shi. Ni, so Simki Shis, Shingazini, Shi Tango Subjengi Namsha Korona lit to Yomata. Sawani lit to Yomare. She Nam Subjengi Shinala Neta and Dugala. Debata Sus. Debe kamda sugi kam nisi Debe kamla doa rirutine dinala mita tunruke takchi shema donga zo nezile tugu yo martadi. Di indugala shija sede shitagi capjumburta di nane tanda tunruta mi nane da tanda shipsakbu shida kala kabu mero samudu. Di indugala shija capse se tayo mares da gyumzendir da shija capse tayo mares. Da shija pa tsebale shija hakuni du suresna da nganzu shede de nang sheba nam she sede da sem shede shagorwa da semgi shija indi tsede na kala kaku shujires di indu kala sheja la matsepa ta koru sheja la yebe moba ga chadi shebe koron ting le yede da di passe shana ne sheja ta zobares ke sheda di da ni shedi gyunzen da wudi di chisushi.
So when we talk about the limits of knowledge, so when in Tibetan we talk about the knowledge, it's called sheja. That means something that is knowable. And so when talk about the phenomena that is knowable or knowable by our consciousness, that means there's no limit for this kind of the phenomena, the knowable phenomena. There's no limits, and for that I think from both scientific perspective and Buddhist perspective, they both believe that the knowable phenomena is unlimited. Now, when we talk about the limits of knowledge, then it talks about the ability of our consciousness for knowing the existence of this knowable phenomena. And now, in Buddhism, when we talk about the phenomena, there are different types and different levels of phenomena. And the gross level of this knowable phenomena is called the physical phenomena. And they are like the form realms and other realms. And now when we are talking in science, when they talk about the knowledge, it's only talking about this physical realm, and that's in physical realm, from Buddhist point of view, of these form realms and formless realms. And even these formless realms are considered as physical realms. So in science, we talk about these physical realms. We also don't talk about these formless realms. We also only talk about the form realm, and we only talk about the human beings and the sentient beings and the physical world that we know about. And so that's why, from Buddhist point of view, the phenomena, the knowledge is unlimited. This knowable phenomena is unlimited, and you cannot go after without changing your mind. Just with this gross level of mind, you cannot go after and know everything, learn everything. So instead of trying to know everything that is there in the universe, you can change since our consciousness is the one that knows the knowable phenomena. You can, instead of going after the phenomena, you can change the mind itself or the consciousness itself. And from Buddhist point of view, when we talk about our inability to know the phenomena, it's because of two kind of obscurations. And if these are kind of defilements that blocks our mind to engage directly with the physical world, and if you, through mind training, if you can eliminate these two obscurations or defilements of the mind, then you don't need to, that is the end of knowing. That means at that time you reach a certain stage, your mental level or the mind reach a certain stage that you know everything by itself, kind of.
If I may add a tiny bit.
Yeah.
As a Buddhist, when I talk about limits of knowledge, I think I'll be shooting in the dark with the nearest gun, because I don't really know. The only person who can know the limits of knowledge is because whatever that is knowable is your perception, something that has arisen from your awareness, is how we explain. And so it's like rather than going outside and knowing everything, it will be like if you can come face to face with your awareness, and then you will know everything. But if you want something in Buddhism that could be considered outside the limits of knowledge, I think I can give you an example. In Buddhist epistemology, I think that is the correct word, Samarripa. We have definition for everything that we know, but we cannot give one definition that can define everything, in detail, everything. That is one definition that can define everything in detail is something I think you can say Buddhist is something beyond Buddhist limits of knowledge. Other than that, we can just do guest jobs and I don't know.